The tank has the shape of an inverted circular cone with height of 10 meters and the radius is 4 meters. Okay, it is filled with water to the height of 8 meters. Okay, so let's see if I can pick a watercolor here. So let's say that's 8. So it looks something like this. Okay, so the water is up to that level. Okay, so find the work required to empty the tank by pumping all of the water to the top of the tank. Okay, so the reason why this is not something that we can just get the mass of this and times it by this height here, which is 2 meters, is because it's different mass depending on where we are. Okay, where we are and how deep we are. The way we want to think about this is to cut it up into tiny little slices. Okay, so maybe I should change the color here. Okay, so let's say this little thickness here, because I labeled this from here to here as small h and this to be small r, and they're gonna vary, right, as the water level decreases. So let's call this dh. Okay, first of all, mass is density times by volume. Density is given 1000. Okay, and the volume is going to be, for this thin slice, it's going to depend on pi r squared times by, I should call this delta h first. Okay, of course, we're going to make this infinitely small and becomes dh later, but let's write delta h for now. So this is the volume. And the expression for the force for this, okay, or weight is going to be this times by 9.8, right? 9.8 times by 1000 pi r squared delta h. So that's 9800 pi r squared delta h. Okay, and the work done by this single slice to lift it off out of this tank here is going to be 9800 pi r squared delta h times by, if this is h, and since this is 10, we have to lift it by 10 minus h. Okay, and we have to do that for every single slice. To represent the sum of all those slices, that's going to be integral, where h is, right, 0 all the way up to 8. And if you make the slices really small, right, really small, then it becomes dh, okay, and we have 10 minus h. The only thing that we have to fix now is this r, right? This is a function of h, so this r needs to be converted into h, and we know that like h over r, or sorry, let's do r over h. R over h is going to equal to 4 over 10, which is 2 over 5, right? So r is equal to 2 over 5 h. Okay, so this is 2 over 5 h all squared. Okay, so this is 9800 pi. You can pull it out in front of the integral. If you square this, you get 4 over 25 h squared 10 minus h dh. Okay, so this simplifies to 1568 pi, and here let's expand this. You get 10h squared minus h cubed. Okay, and it's going to be 10 over 3 h cubed, 1 over 4 h to the power 4. This, okay, so it's 3,362,827.8 joules. Okay, so that's how we do the work.